Hi, Torkil.
Hello, Alan.
So, for the audience, Torkil is the co founder of Neptune, and you're also, can I describe you as the lead developer?
Lead engineer,
Lead
maybe.
engineer. What's the difference between developer and engineer?
That's what's the difference. I guess engineer is like a broader term. Um, I like to think about programming as I don't know, synthetic engineering, where you're an engineer and you get to build all these bridges and highways and stuff like that, but you're not dependent on the trucks
Physics.
coming in. You're not dependent on the cement being delivered at the right time. It's like engineering, but it's synthetic, and that way you're only constrained by your own productivity.
All right. Um, what can you tell us about Neptune, the state of the code base, what happened in the last week? Let's start with
Well,
the last question. What happened in the last
well,
week?
yes. Well, I think that the short answer is we progressed towards the recursive verifier. So as you probably know, the holy grail of stacks is to be able to write a verifier for your stack proofs in the assembly language that your virtual machine understands. And yeah, I'm basically working towards that, and it's small steps. I tend to work, when I'm programming, I tend to write programs bottom up, whereas other developers some often write top down, and it has its sometimes it has its drawbacks. The way I'm doing it, like if you flip the order of arguments in some function, then you might get more efficient code, and you can only realize that after. Sometimes you can only realize that after the fact. But yeah, the short answer is we are progressing towards the verifier, and for the people who are a bit more into this, the last step that we managed to do was constraint evaluation. That we are checking that the constraint evaluation that we're doing in what we call on the host machine, when you're programming something in Rust directly and it runs on your machine, that those calculations agree with whatever is going on inside the virtual machine.
And so the recursive verifier is not there yet. Is there a roadmap on that might indicate when it might be there?
Um, yeah, there is. I would say if we focus on this and we put our minds to it, and the and I get some help on this, I would say 2 weeks should be possible.
2 weeks.
Yeah,
It's awesome. We'll have you back on the show in 2 weeks.
to hold me to my words. Huh?
All right. So that's what's happening for the virtual machine. What's happening in other respects?
Yeah. So just to give a quick overview, we have 5 repositories that we are actively working on.
Why does any project need five
Well, do
repositories?
we do we need it, right? Like that's always that's a good question. Could we just do everything in one repository? You know what, we probably could, but it would make it harder for other people to make use of the things we have invented throughout the last 3 years.
Such as?
Well, you invented quite a few of these cryptographic primitives. One of them is the hash function that we're using, tip5. You not only invented it, but you also implemented it, I believe. And then we have an MMR implementation, a Merkle Mountain Range implementation that we use for our mutator set. And yeah, guess we have a few categories, right? We have cryptographic primitives that we're working on. Then we have the virtual machine that includes a stack engine. Then we have a standard library for this virtual machine that that makes common operation like pushing to a list, popping from a list, working with U64 data types, U128s, and course also some cryptographic primitives that makes that easy. Then we have a compiler for the that compiles from Rust, or technically a subset of Rust, to the Triton VM assembler.
So I'm counting four repositories, right? Cryptographic primitives, the virtual machine, standard library for the virtual machine. Well, the virtual machine is more of a Stark engine because the Stark prover and verifier is there too. Then there's a standard library for the virtual machine, and then there's a compiler.
Yes.
What does the compiler do?
Well, the compiler allows you to program for the virtual machine in Rust.
In Rust.
Yes, but I should say it's a subset of Rust, because Rust is a big language and we only support.
But what do these four repositories have to do with blockchains?
Well, the consensus logic in our blockchain will be programmed for in Triton VM. So and Triton VM.
So that's using the Stark engine in combination with the standard library for which you need to write routines.
Yes.
And possibly even cryptographic routines. So that ties together four repositories already.
I would say so. Yeah. And well, you mentioned four repositories, and the fifth repository is where we have our client that we call Neptune Core.
Got it. And so as an end user, you need to download Neptune Core and install that.
Mm-hmm.
But I bet it depends on the four other repositories. Is that correct?
Currently, it only depends on three of them, which is the cryptography library, 21st, Triton VM, and the standard library. It does not currently depend on the compiler. And it's not certain that it will. It's possible that we just want to write some of the programs that we're going to need in Rust, and then import the assembly code that the compiler spits out.
And so if you want to fool around with Neptune, maybe run a node and maybe even contribute some code, where do you start?
Honestly, I think it depends on your background. Like if you're a cryptographer, and you have some Stark experience, I would say have a look at Triton VM. And if you're more into application development, start with Neptune Core. Start with the client, the core client, and download that. And if you're a guy who likes to program assembler code, then have a look at the standard library and see if we're doing anything stupid. See if you can optimize anything there, or make generalizations, or write some new snippets there. And if you're a compilers guy, well, then Tasm-Lang, as we call our compiler currently, would be the place to start.
And which of these repositories are going to be relevant in a world in the maybe not so near future where external developers develop apps that live on top of Neptune?
Well, certainly Neptune Core, because that would be the way to deploy these apps.
That ties everything together.
You're going to need that. And then it depends on the level of control you want over your smart contract. Do you want to write it in a relatively high level language like Rust, or do you want to write it in assembler? I guess the most accessible part would be to write it in Rust. So for most people, it would be the compiler that they want to look at, and then they want to look at Neptune Core.
But they wouldn't need to contribute to the compiler in order to use it, would they?
No, they would not need to contribute to the compiler, but they still need the program.
So they still need the program.
Yes.
Got it. All right. So what's the state of these repositories? Are they finished? Are they close to finished?
Well, I guess software is never really finished, is it? I think on the team we are quite good at testing, so I feel like they are in a solid state. All the repositories they are tested fairly thoroughly. Where do we need I guess a big there's two major things missing, right? From there are two major components that are missing. That is the reason that we haven't launched yet, and it is the requifier that I'm currently working on through the compiler, and the consensus logic that you're working on. And at one point, hopefully rather soon, we'll have a requifier for Triton VM. We'll have a recursive verifier, and then we're gonna have to look at how we take the consensus logic that you're currently writing in Rust and get that to run in Triton VM. Do we want to use the compiler for everything there, or do we want to use it for anything at all, or do we just want to write everything in assembly? That's a decision we haven't quite made yet, I think.
Correct. And I guess it also depends on running times.
It absolutely does.
Which we don't have yet.
It depends on running time, and compiler optimizations is not really anything I have attacked yet. So yeah, running times currently will be better if you program things directly in assembler than if you go through the compiler.
All right, so we've talked about the repositories. What about binaries? What are concrete programs that you can run? How many are there, and how are they scattered across these repositories?
Well, I'm not sure I understand your question fully.
Well, are these repositories libraries, or do they produce programs that you can execute?
Okay, yeah. So the cryptography library is a library. Triton VM, I think, is a library.
It is mostly a library, but there is this one executable called
the debugger. Yeah, the debugger. So there's a really cool debugger that Ferdinand has developed for Triton VM, and it works really, really well, and it's a good way to debug your programs. It does, however, of course, require you to be able to read assembler, to read the assembly language that this virtual machine runs. And
if you want to learn more about that assembler language, what do you do?
You go to triton-vm.org, and you press the spec button there, and that will, I think then you need to press a link to go to the instructions, and then you'll see the instruction set. And that's how you learn the assembly language. So cryptography library and Triton VM are mainly libraries. Then we have the standard library. It's also a library. Then we have two executables: the compiler and Neptune core.
Neptune core is an executable.
Yes.
But I was under the impression that it was a daemon. So daemons can be executables, right?
Well, it's in Rust. I think you get two options when you make a new repo. One of them, are you building a binary or are you building a library?
Got it.
And Neptune core is a binary.
Right. But there are other binaries in Neptune core, the repository also, aren't there?
A few. I think there's a wallet generator in Neptune core.
The wallet generator has been moved to a command line command for the command line interface.
Got it. So
which is one of the executables.
So there's a command line, and then there is the great UI that you made, the dashboard. That makes it much easier to interact with Neptune core than having to write commands through the command line.
So Neptune core is running in the background, and then you can send and receive money using the dashboard, and you can use the command line interface to check things like how many nodes am I connected to.
Yeah, you can use the dashboard. You can use the dashboard for that too. I would say you can use the dashboard for all you want to do as an end user. But if you want programmatic access to Neptune core, you want to use CLI. and it's possible that you want to use CLI for a few other things. You might want to use it for just like if you want to clear the list of band nodes, for example, then currently you have to do that through the CLI. You can't do that through the dashboard. But there's tab completion on the CLI, and that makes it quite ergonomic to use. There's tab completion if you run Linux. I don't think we have it. We don't have it for Windows. I don't even know if it exists, but it doesn't work for Windows. The tab completion.
One more question. I bet that in the audience, someone is dying to write a block explorer for Neptune. How does that integrate into the libraries and or binaries and or daemons and executables?
If someone were to write a block explorer, I would suggest it would be a new repository. So don't try to make it as an addition to an existing repository. Make a new repository and define your block explorer in terms of the command line interface. No, not the command line interface, like the JSON interface to Neptune Core. So figure out what the endpoints of Neptune Core is, and figure out how to interact with that programmatically through HTTP requests to local hosts.
And to figure out what those JSON RPC endpoints are, you can look at examples provided by the dashboard and the CLI.
Yes, I would say the way the CLI works is that it sends these HTTP requests. So just by looking at the commands you can make through the CLI, you should be able to figure out what the endpoints are.
And what if some are missing?
Then they should make an issue. If there are endpoints that are missing, they should make an issue on Neptune Core and say, please give us this endpoint, maybe provide an example for why you need it, or describe why you want it.
And maybe make a PR2 while
yes, absolutely. That would be great if they can both report the problem and solve it.
Awesome.
That's awesome. That would be awesome.
All right. Thank you for your time, Torkild. Thanks for watching. Thanks for listening. And if you want to find out more about Neptune, the website is, as always, https://neptune.cache. If you want to leave a comment on this video, please go ahead. But you should know that more people lurk around on the forum talk.neptune.cache. I'll see you next week. Take care.